Bismillahirrahmanirrahim. Assalamu alaikum students, I hope you are here and healthy. In this class we will talk about the Schrodinger equation. This is a very important topic. In this lecture we will discuss the introduction, the derivation of Schrodinger time independent wave equation. Let's first of all talk about Schrodinger. In 1926, an Austrian physicist Schrodinger developed wave mechanical model of atom. This model counts into the wave and particle nature of electron, which is wave particle duality. From the Bohr's perspective, we know that electrons revolve around the nucleus in a fixed path, which is known as shell or orbit. And this electron is only found in this path. But the Schrodinger says that this electron is wave-like motion in three dimensions. This means that this electron is revolving around the nucleus in three-dimensional motion like standing wave. This electron can be found here and here, but the maximum probability of finding electron is in this center. This is the concentration is maximum of electrons. So as electrons obey the wave-like motion, this means that this electron will obey the wave equation. So as you can see from this graph, we have, let me erase this. This is, for example, a particle which has angular velocity omega, radian per second. This moves from this to this point P, and it discovers a distance from 0 to P. Now let's suppose you can see this sin theta equals to PC is perpendicular or hypotenuse, so the PC divided by PP. And here you can see this PC is equal to psi divided by A. The psi is the vertical displacement in this graph. At this point the time is 0. After covering this much distance, the time is taken as t. Let's suppose t. And this whole is equal to 2 pi. Now from this figure we can see A sin theta equals to psi, or implies that psi is equal to A sin theta. This is called the wave equation. Now you can see, let me write this over above. But again, let me check the video is playing or not. Okay. So this psi equals to A sin theta, and we know that omega is equal to theta divided by time. Sin, this implies that theta is equal to omega t. So we get a sine omega t. Psi equals to a sine omega t. And we also know that omega is equal to 2 pi f. This is equation number 1. Let's suppose this is equation number f. And also know v is equal to f lambda. Lambda equals to v divided by f. And also know that v equals to s divided by t or x divided by t. Now let's little bit rearrange it. This omega equals to 2 pi v is equal to f lambda 2 pi, and this f equals to v by lambda into this is t, this is omega equals to 2 pi lambda, but erase this filhal. This time you can see 2 pi v is equal to x by t, and this is lambda. Put this omega, the value of omega over here, you get a sine 2 pi x divided by lambda t into t. Cancel this one. We get psi equals to a sine 2 pi x divided by lambda. This is equation number b. Now taking the partial derivation of this equation, del psi divided by, with respect to x, del psi divided by del x equals to del divided by del x into a sine 2 pi x divided by lambda. Now let me erase this side, but first let me again look to the video. Okay, that's fine. We clear this one too. Now from here you can see del psi divided by del x equals to, this a is constant, so a, and from here we can get the derivation 2 pi divided by lambda into cos, derivation of sine is cos 2 pi x divided by lambda. Now taking another derivation again, so we can get del square psi divided by del x, again derivation, partial of equation c. Okay, del x square equals to, this a is constant, this 2 pi by lambda is also constant. The derivation of from this first, this is theta, so you can see that this derivation is again 2 pi divided by lambda, and the derivation of cos is minus sine, so minus sine 2 pi x divided by lambda. Now take this minus over here, we can get this equation. Now moving further on, this del x square equals to minus 2 pi lambda, 2 into 2 is equal to 4 pi square divided by lambda square a into sine 2 pi x divided by lambda. And you can see this a sine 2 pi x by lambda is equal to this equation number b. By comparing equation number d and b, we get del square psi divided by del x square equals to minus 4 pi square divided by del square into psi. This is equation number E. Now let me erase this side. This much clear to all of you? Okay. Let me check the video again. Okay. So now you can see this, we get this equation. As you can see, the Schrodinger says this, we apply this equation to 3 dimension, and this is with respect to x. This is the 1 dimension. You can now write it as del square psi divided by del square x. But before going to 3 dimension, let first more simplify this equation. 4 pi square divided by lambda square psi. It's from de Broglie's equation. From de Broglie equation. Equation, we know that lambda is equal to h divided by p, which in turn is equal to h divided by mv, where m is the mass and v is the velocity and p is the momentum. From this we conclude that h square equals to h, lambda square equal to h square divided by mv square. Put this equation F in equation number E. Then we get del square psi divided by del x square equals to minus 4 pi square m square v square divided by h square. This is equation number G. As we know that the kinetic energy equals to half mv square. Now dividing and multiplying this equation by 2, we get del square y divided by del square psi divided by del x square equals to, this will give us minus 8 pi square m square v square divided by 2h square. This can be written as minus 8 pi square m into 1 over 2 m v square divided by h square. This is equal to the kinetic energy. So the final equation we get is del square psi divided by del x square equals to minus 8 pi square m into k into e ke divided by h square. As we know that the total energy equals to, this E represents the total energy, which is equal to kinetic energy plus potential energy. So this gives us that kinetic energy is equal to total energy minus potential energy, where V represents the potential energy. So you can say that del square psi divided by del x square equals to minus 8 pi square m into E minus V divided by h square. This is the equation number I. As you know that the Schrodinger equation is applied to 3-dimensional spaces. Because the motion of electron is in 3D. So we can say that this equation can be written as del square psi divided by del x square plus del square psi divided by del y square plus del square psi divided by del z square is equal to minus 8 pi square m into E minus V divided by h square. This is the Schrodinger equation. This can be written as minus del square psi divided by del x square equals to plus del square psi divided by del y square plus del square psi divided by del z square plus 8 pi square m into E minus V divided by h square. This is the final equation of the Schrodinger time independent wave equation. This is the Schrodinger time independent wave equation. This equation can be written as, let me erase this side. And this complete operator is equal to del square psi. Here the psi will, here is psi also. Here is also psi. Cos minus 4 pi square m square psi, because in the first case is a psi, so don't forget the psi. This del square psi plus pi square m e minus v divided by h square into psi equals to 0. This term is called the Laplacian operator. This is the replacement of this x, y and z. We can also write this equation as in term of h cut, where h cut equals to h divided by 2 pi. So if we square h cut square, this will give us h square divided by 4 pi square. Now to compare this equation with this, we get del square psi plus 4 into 2 is equal to 8, then we get 2 pi square cancel, we get 2m divided by, instead of h cut square into e minus v into psi is equal to 0. This is the final equation of Schrodinger time independent wave equation. It's all about this. In the next class we will talk about the time dependent Schrodinger wave equation. Inshallah. Remember me in your prayers. If you have any confusion, you may ask without a doubt. Allah Hafiz.